Okay, class, so today's lesson is on word problems. All right, so linear equations, what we've been studying, they can be used to represent real-world problems. And we've already written equations in algebra. We didn't do too many word problems. This is going to be a bit of a challenge for us. So typically we have our equation y equals mx plus b. And we have been telling you, well, m is your slope, and sometimes it's referred to as your your rate of change. So we have to be able to figure out what our rate of change is, or what our slope is, and then put that number in that location of the equation. And then we have our plus b. Our plus b is a constant value because there's no letter beside it. Its value always stays the same. And the number that stays the same, that's called the constant. So we have two numbers that we have to look for in our word problems, and then we just have to write them in that location. Now, what we try and do is we try and use, instead of x and y, we can use descriptive letters. Okay, so for example, H could represent hours, or if we're talking about pay, what letter could we use? We could use the letter P. Or if we were talking about days, we could use the letter D. So you try and use descriptive letters as we're doing real world situations. If you're not comfortable with that, that's okay. Let's try and work through these, okay? So again, here we have our rate of change, which is our m value. So y equals mx plus b, okay? M representing our rate of change, and then b is our constant. I know it's weird, constant should be a c, but it's not. They use the b letter. I'm not sure why, but that's what they do. So we have a base salary of $40,000 plus a commission of $300. A commission means money he makes on what he sells. So stuff like salespeople, they're usually making some kind of commission. This is a base salary. So if he sells 1,000 machines, he gets $40,000 plus his commission. If he sells 0 machines, he gets $40,000 plus commission. That does not change. This value then is constant. But what changes is the $300. If he sells a machine, he gets $300. If he sells 2, he gets 6. If he sells 3, he gets 9. So that's what's changing. So y equals 300 times x plus $40,000. Okay. Now to use descriptive letters, we're trying to find his income. So what letter could we use? We could use the letter I. Okay. So his income would replace the y. Now we're using a real world letter. Then 300 is multiplied by what? Well, every machine he sells. So for every machine, we could use the letter M. So you'd multiply 300 times how many machines he sold, M, plus $40,000. So now we went from typical math, y equals mx plus b, into descriptive letters. I equals 300 times m plus 40,000. So what we want to do now is we want to maybe get some information from this so we can graph it, so we can do the presentation and show your boss how much money this guy's making, and of course how many machines he's selling. And so the boss can then take that and try and get other employees and say, hey, look what this guy can make. You can make that too if you come work for us. So let's create a table of values. First of all, when we're creating table of values for real situations, now, not all the time, but for us, for real situations, you want to have 0. You'll start with 0, and then you'll just go to positive x values. And the reason why is because for us, and most of these graphs that involve real situations, you'll be using this quadrant. This corner of the 4 grids. This quadrant usually. And I have to say usually because there can be some situations, not that we will see this year, but later on, yes. Okay? So you're going to be dealing with that quadrant only. You're not going to be graphing any of the other 4. Okay? So for us, we'll be looking at this quadrant only, right here. Okay? And that's because usually we sell positives. A person doesn't sell a negative amount of machines. You would sell 0. So let's start with 0. So if x equals 0, in this case we're using the letter M, and we're trying to find the person's income, well, what would it be? Well, we would substitute in, just like we've always done, 300 times 0 plus 40,000. Do you remember 0 is kind of special? It would be 0 plus 40,000. It would just be our constant value. And so that would then be our starting value, 40,000. Okay, now you're not going to just go 40, typically someone doesn't sell 1 machine or 2 machines. They're probably going to sell a certain amount of volume. So we can maybe graph different numbers than just 0, 1, 2, because he's going to sell a lot more than that. So we have to come up with, we have to use some realistic numbers. But we also want to make sure we have easy math. Okay, so how about we sell like maybe 10 machines, maybe 20 machines, and maybe 30 machines? Because that's probably more realistic. Otherwise, the company will go broke if he actually doesn't sell anything. So then we can substitute in I equals 300 times 10 plus 40,000. And you guys see where this is going. Okay. And so I equals 3,000 plus 40,000. Do you see why I chose 10? It's an easy number to work with. Okay, and so his income is 43,000. Okay, good. And so then you can do 20 as well, substitute and figure that out. I equals 300 times 20 plus 40,000. And you'd probably see, well, that's 46,000. If it's 30, it's 49,000. Okay. There we go. So now that we have those values, we can graph the values. The first thing you have to do when you're graphing, number 1, is make grid lines. Okay, so you got to make some grid lines using your ruler. Luckily for me, I got a little helper here, okay? All right, so there you have grid lines. Now, if it doesn't work out, sometimes you actually have the lines right here, and then you can graph easier and make your scale easier. For me, I've done these notes before, so I know I'm going to put my grid right here. Okay, and so now I can then do my figure out my scale. So for my scale to find a scale that works. So I have 10, 20, 30. Counting my Y's, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20. So I can go 30 divided by 20. Equals 1.5. Now, it would be kind of awkward to go up by 1.5. So I would round up. So I would say 2 machines per 1 square. Okay, and that's because we have 30 machines and we have 20 squares. So we're going to go up by 2s. All right, so we can simply then count. Let me just make this bigger so it's easier to do. We always want to start at 0, and we go 2, 4, 6, 8, 10. So right there we could put a 10. Oops, that looks like a 16. 10. And then we could go 2, 4, 6, 8, 30. All right. And then we could go, 30, 20, first time counting, 2, 4, 6, 8, 30. Now, the reason why you want to make sure you plan out your scale is you don't want to scrunch your graph in one little section. You won't be able to read it and get information very easily. You want to plot as many points as possible and spread it out properly. Okay, so spread it out and use a large portion of the graph. Don't scrunch it into one little area. Now we have to do the other scale. Okay, so then we have to count how many squares we have going up. So going up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25. So we have 25 going up. All right, so up, which is vertical, we have 25 squares. Okay, and this here was horizontal. Good. So according to 25 squares, and we gotta go to 49. Okay, so 49 over 25 squares. And that's gonna be dollars. 25 squares. And so we just simply divide 49 divided by 25, 1.96. So what should we round up? What should we go to? We should go to 2 again. So $2,000 per 1 square. Okay. So starting at 0, we're going to go up 2, 4, 6, 8, $10,000. 2, 4, 6, 8, $20,000. Let me just view this. And you don't have to tick every square. Okay, you see I'm not doing that. 2, 4, 6, 8, 30, $30,000. 2, 4, 6, 8, $40,000. 2, 4, 6, 8, $50,000. Okay. And you can erase all those lines and erase that. Let's go undo because I don't want to ruin that location. There we go. 30,000 right there. So now I can go and I can plot my points. Okay, at 0 we have $40,000. That's an important point. Your constant is always going to be on your y-axis. Okay, if you haven't noticed that yet, that's something that we always do. At 10 we're at 43. So 10 is on, let's see, go to 10, go all the way up. It's going to be on this line here, and that's 42. That one's 44, so it's going to be right in the middle. Okay, there's 43. And then we have 46 at 20. So 20 will be on this line, and we're at 46, which means we're right here on the line. And then 30 is going to be this line right here. And at 30, we are at 49. So again, we are right on the line. Okay, and so then you would take your line and your ruler and you can make lines, because it kind of makes sense to have points in between because we're selling so much So there's question 1 with our line, and from this line we can get information. For example, we can estimate if he sold 40 pieces of machinery, we go up, and we can see, even though we're off the grid, that's going to be over $50,000 of income. Okay, as well as we can then also predict information in between that. So for example, if he sells 25 machines, we would go up to our line and over, and we could see that's going to be about $48,000. So we can use our line to interpret information, predict, interpolate, and extrapolate. So basically what I'm saying is we could figure out some possible income levels in between here. And that's going to be very useful for making predictions for the company as they make decisions around their finances and hiring and firing people. So really, it's just kind of a business sense to make this line. Here we go. Next one. Mr. T, he's on a diet. He currently weighs 260 pounds. He loses 4 pounds a month. So we have to write an equation. All right. So let's start with y equals mx plus b. Y equals mx plus b. We're looking for those numbers. First of all, what kind of number represents loses 4 pounds? A loss would be -4. Now this happens a month. Okay, so that would be our rate of change, and the keyword is So you're looking for words like per, each. And when we have those words in our sentence, that's kind of centered around our rate of change. So we would have a -4 m value, and the starting weight would be our b value, plus 260. Okay, so often your constant is often what we start with. Okay, it's often a starting number for our relationship in our graph. So that's one thing you can also look for, those kind of key words. So we can get y equals -4x plus 260. So to use words, we can use m for months and weight. So weight equals -4 times m plus 260. You'll notice this is usually going to be a capital letter. Okay, it's usually a capital. Now, if you don't do that, I'm overlooking it for this unit. In grade 10, we don't. We get a little bit more finicky. But as we're learning this, it takes some time. So we start at 0. And then we don't want to weigh him after just 1 month. We're going to pick some better numbers. So let's say he weighs after 2 months and then after 4 months. So now we can go and find his weight. So W equals -4 times 2 plus 260. -8 plus 260. So really we're just subtracting 8. So W is going to be 252 pounds. And this would be our starting value of 260. And then we can go and substitute in the other number, but some of you may have already got it. -4 times 4 plus 260. And W equals -16 plus 260. W equals, let me go here, 260 minus 16. It's too early for me. 244. There we go. So 244 pounds. Okay. So now what we want to do is we want to then graph this. All right, so we're going to graph this here. So we're going to come up with our scale. This was 20. So we got 4 months, 5 by 20 squares. So we go 4 divided by 20. And it's 0.2 a square. So let's go maybe half a pound a square. Let's round up. So half a month, 0.4 months per square. So making our scale again. Here we go. Good. Supposed to be 1, supposed to be 2, 3, 4. Okay, so now I'm looking at this, I'm thinking, we're going to have our entire graph on less than half of the grid. Well, that doesn't make sense. It's going to be a really squashed in graph. So obviously 0.5 months is not going to be a good scale. So when I did this, I got 0.2. So let's round up to 0.25, 0.25. So each square represents a quarter of a month. That will spread things out. So now we have 0.25, 0.5, 0.75, 1. So we can continue that every 4 squares. 1, 2, 3, 4. There's 2 months. 1, 2, 3, 4. There's 3 months. And 1, 2, 3, 4. There's 4 months. Nope, I miscounted somewhere. 1, 2, this is 3 here, and this is 4 there. Now you can see instead of being scrunched in here, all in here, now it's spread out further, a better graph. So sometimes you have to repick your scale. I just rounded up way too high. So let's do my vertical then. I am going down 16 pounds. So what we can do is we can kind of change this a little bit so that we have 16-pound loss. Let's say 20 pounds. Actually, no, let's go 30 pounds that we're going to lose over 25 squares. So I believe that's 1.5. 30 divided by 25, 1.2. So let's go 1.5 pounds per square. Okay, so what we're going to do though is we're going to go up to about 230. So we're going to start here, go and right here we will go 230. Now the problem with this is it skews your graph and it misrepresents it. I feel if you are aware of that, that's okay. You'll still get to the same rate of change. You'll still get the proper numbers graphed, but it just skews the picture, so it gives it a different representation. Okay, so this skews the graph. And not the numbers, but just the picture. So instead of having a slow rate of change, we will have a fast rate of change. That's what it does to your picture. But it can make it easier to graph. Okay, so let's go 230. 3, 6, 9. Okay, so now as I look at this, I'm thinking, well, 1.5 pounds per square, that's going to be tough for me to do. So let's not do 1.5. Let's just increase that to 2 pounds per square and see where we get. Okay, so going up by 2s, it's going to be way easier. 2, 4, 6, 8, 240 will be right here. 2, 4, 6, 8, 10, 250 will be right here. 2, 4, 6, 8, and 260 be right here. 2, 4, 6, 8, 10, 270s right there. Now looking at my graph, I am going to be spread out. I'm not going, and I have enough space, so this looks like a better grid for me rather than going up by 1.5s, which can be a little bit more challenging. So you got to pick your grid smart. So let's graph now. 260 right here at month 0. At month 2, we're at 252. And now I'm really liking my scale, right? 252 right here, super easy. I should zoom in so this is easier. And month 4, 244. So month 4 is along this line, and 244 will be right there. Awesome. So now I'll go and get my line and make a nice, beautiful, pretty line. You'll notice how now for my line, I'm just using an arrow. And that's because I definitely have a stopping point. I stop here. I do not go into negative months. although negative months would be before the diet started, I don't do that. It doesn't really make sense because I want to graph just when I start the diet. So that's why we're just dealing with positive month values in this quadrant. Okay, so now it says, what about how heavy is he going to be when he reaches his goal weight of 220 pounds? So number one, you could use graph. But ours isn't long enough, right? So we don't have enough months graphed. So instead, you will substitute and solve. So instead, you're going to substitute into the equation and solve. And this is the power of linear relations, is that you can take your equation, W equals -4 times m plus 260. Now I want to know 220 pounds, so when will Mr. T be in his fighting weight? And if you watch the movie Rocky, highly recommended, you'll see who Mr. T is, or watch the A-Team. So then I'll just do my solving. So I will get -40 equals -4m. And so then divide by -4 and get 10 equals m. So it'll be 10 months. So in 10 months, he will be 220 pounds. Okay? Great. So I substituted and solved and found my answer. Now, this one's going to be a little bit different. So sometimes both variables are affected by a rate of change. So we have children's tickets. Okay, that's our one variable. So instead of an X or a Y, we are going to use the letter C. And then we have adult tickets. So instead of an X or a Y, we will use A. All right. Now, good. And it costs $7 each. What would be the total amount of tickets? Is 210. So what we have here, okay, X is the number of children's tickets, and Y is the number of adult tickets. So it's $3 for each ticket for the children. So it's 3 times C. That's how we calculate how much money was brought in by the children's tickets. Plus, it's $7 for every adult's ticket. So 7 times A would be 7A. And that equals a total amount of money of $210. There's our equation. It's in the different format, okay? So the question is here, if 24 adult tickets were sold, how many children's tickets were sold? So we will say A equals 24, and we will substitute that in. So 3C plus 7 times 24 equals 210. So we just brought this down and said A equals 24, and we substituted it in. And so then we do our math, 3C plus, it's too early, 24 times 7 is 168. Mr. Parker Shiving giving more space, 3C equals 210 minus 168, and we get 42, divide by 3, and you get 14. Okay, good. So complete and graph so that means that there's 14 children's tickets if we sold 24 adults tickets. Complete a table of values. So this will be C, this will be A. We're not going to graph this one, not today. This will be fine for us for right now. Now I want to go over the homework and give you some help with the homework. So for the word problems here, you have Mr. Fantastic. Good. Today the plant's 5 centimeters high and has a growth rate of 1.5 per day. So this Y will be the H, the height, and X will be the number of days. So let's start with day 0, and then let's go with day 10, day 20, and day 30. So you can substitute in and solve. Okay. Actually, those numbers might be a little high. Let's go 0, 5, 10, and 15. Okay. Good. Then you can then substitute and solve.